Section 14.5, reactions of acids and bases. One of the reactions that acids and bases undergo is called a neutralization reaction. And we talked about these in a previous chapter about chemical reactions. These involve the reaction of an acid. In this example, it's hydrochloric acid with a base, potassium hydroxide. And these almost always form water and salt. And remember, by salt we mean an ionic compound, not necessarily sodium chloride. We have learned in the past how to write net ionic equations. And if we take this and write the net ionic equation, remember that's where you take anything that's aqueous and you separate it into the individual ions. Something that's liquid like water would not be separated into ions, or a gas or a solid would not be separated. This would be separated. You look for the ions that are the same on both sides. Those are the spectators. They're just watching. They're not actually participating. You cross those off, and what you have left is the net ionic equation. For most neutralization reactions, the net ionic equation is the same. Hydrogen ion plus hydroxide ion forms water. And so they all have that as their net ionic reaction. Here's an example of a reaction with carbonates. If you have carbonates or bicarbonates, so you recognize these because they'll have the carbonate ion or the hydrogen carbonate ion, the bicarbonate ion. When these react with acid, they produce water, gaseous carbon dioxide, and a salt. So they're going to be a little bit different because we've got salt, an ionic compound, and water, but we also have carbon dioxide. And this kind of a reaction also falls into the category of a gas evolution reaction because it gives off a gas. And this is what would happen if you mixed vinegar with baking soda. It'll fizz, right? And that fizziness is the carbon dioxide. The carbon dioxide is being produced because of the bicarbonate ion. So we need to know how to write equations for neutralization reactions. So let's write a molecular equation for the reaction that occurs between aqueous phosphoric acid and aqueous sodium hydroxide. These neutralization reactions fall into the pattern of the double replacement reaction, and I think that's the simplest way to look at them. So to write an equation, we need to write the formulas for each of the compounds. And those are given here. So we have H3PO4. And we're told that's aqueous, so we'll put AQ. And the other reactant is sodium hydroxide. I'm going to leave a little space there in case I need a coefficient. And there's my arrow. This is the acid. We will go back to the beginning of this chapter and talk more about how we identify acids, but even with our present knowledge, we know that an acid starts with H. And sodium hydroxide, being a metal hydroxide, is a base. So here's our acid and here's our base. We can write the equation predicting the products by looking at this as a double replacement reaction. In a double replacement reaction, we take this compound and separate it into ions. We take this compound, separate it into ions, and then we just have them swap partners. What are the two ions present in phosphoric acid? Phosphate and hydrogen ion. So this compound contains phosphate ion, PO4 3-, and hydrogen ions. There are 3 hydrogen ions, but we're not concerned with that right now. We just want to see what 2 ions that are in there, and we're not concerned with how many of them. What are the 2 ions present in sodium hydroxide? Sodium ion, which is Na+, and hydroxide, OH-. Very important to have the charges on these ions. Now we're going to swap partners. Remember, you've got to have a positive and a negative. You can't put hydrogen and sodium together. They just won't get along very well. So on the other side of the arrow, I'm going to write these formulas with their new partners. So I've got hydrogen now with hydroxide ion, and I've got sodium with phosphate ion. Just switching partners. By writing these formulas underneath, I see the charges, and this helps me to write the formula for the compound that these two things would form. Now this one's going to be kind of funny, because if we look at that, we'd say, oh, well, one hydrogen ion and one hydroxide ion. And we'd say HOH. And then we look at that. Does that look a little strange? Yeah. It's H2O. So that's H2O. What's the state of water at room temperature? It's a liquid. We're not going to say that it's aqueous, because that would be silly. How does water dissolve in water? Right? Water is water. So liquid is the state for the water. For these guys, we're looking at the charges, +1, -3. So, there's multiple ways to approach doing that. One of the ways is the crisscross thing. We're going to end up with needing 3 sodium ions for every phosphate ion. And that will be aqueous. Usually the salt that forms in a neutralization reaction is an aqueous salt, a soluble salt. But you could look that up in the table of solubility rules and see that sodium compounds are always soluble. So then we need a plus in here. Any questions so far? The next thing is, anytime we write an equation, it should be balanced. Even if the question doesn't specifically mention that, we should balance the equation. Because this is a double replacement and we're just swapping ions, we can treat this phosphate ion as a unit because he occurs over here and he occurs over there. So on this side we have 1 phosphate, on that side we have 1 phosphate. So that's cool. Over here we've got 1 sodium, and over here we have 3 sodiums. So we need a 3 in front of the sodium hydroxide. So this is showing us now, we've got, with the water, with the hydrogens and oxygens, it gets a little trickier. Here we've got 3 hydroxides, and here we've got 3 hydrogens. And so if we think about them individually, we need 3 hydrogen ions and 3 hydroxide ions. And how many water molecules is that going to make? 3. There's 3 hydrogens in this guy and 3 in that, and so over here we need a total of 6, 3 plus 3. We have 3 times 2 is 6. 3 oxygens here, 3 oxygens there. If you want to count all the oxygens, there's 4 here, plus 3 is 7. 3 plus 4 is 7. So that's how it balances out. Now what's this hint talking about? Phosphoric acid is an acid that has 3 hydrogen ions. What is a hydrogen ion? A hydrogen atom has how many electrons? 1. And how many protons? 1. When you make a hydrogen ion, an H plus ion, it's positive because what happened? It lost an electron. If the atom consists of 1 proton and 1 electron, what's left? Just the proton. A hydrogen ion is simply a proton. It's a nucleus that consists only of a proton. So we call this a triprotic acid because it has 3 protons. It has 3 hydrogen ions. H3PO4. There are diprotic acids like sulfuric acid, H2SO4. There are monoprotic acids like HCl, 1 hydrogen ion, 1 proton. Looking at the number of hydrogen ions on that acid gives you a big clue to how this equation is going to balance out. There's 3 hydrogen ions here. We're going to need 3 moles of hydroxide ion to neutralize that. And so it's not a coincidence that there's a 3 here and a 3 there. Any questions? There are other acid reactions. Acids will dissolve many metals, but not all metals. We've seen this reaction, hydrochloric acid and magnesium. We use that to generate hydrogen gas. Sulfuric acid will react with zinc and form hydrogen gas and zinc sulfate. Hydrochloric acid will react with iron, generating hydrogen gas and a salt. So many metals do react with acids, but not all of them. When they do react, they react in a way that causes the metals to go into solution. So when an acid dissolves a metal, it appears that the metal is disappearing, right? We had the zinc strips, the magnesium strips, and we added acid to them, and afterwards we didn't see metal anywhere, did we? Did those zinc atoms, sorry, I've got zinc on the brain for some reason, magnesium, did those magnesium atoms cease to exist? No, they were transformed into magnesium ions, and they were paired with chloride, which is a soluble compound. The magnesium is still there, it's just a soluble compound now. Usually these reactions are going to produce hydrogen gas. The hydrogen gas comes from the hydrogens on the acid. So it's going to generate hydrogen gas. Acids also react with metal oxides, so like potassium oxide or magnesium oxide. These will react with acids, and they will also form water and salts. Do you know what rust is? Obviously, you've seen rust. It's an oxide of iron. Did you know that you can dissolve rust with soda? Any kind of soda is acidic, right? So Pepsi, Coke, whatever you like. It's acidic, and you can pour it on the rusty thing, and it will begin to dissolve the rust. So, your car's not starting because your battery terminal is all corroded and rusty. Pour your soda on it, and it will begin to dissolve the rust, because acids react with metal oxides. They're going to generate water and salt. They'll get rid of a lot of that rust. Write an equation for the reaction of hydrochloric acid with strontium metal. What's the formula for hydrochloric acid? HCl. And what's the symbol for strontium? Sr. So strontium metal is just the element. It's not an oxide or anything like that. So what's this probably going to do? It's going to produce hydrogen gas. Acids that react with a metal produce hydrogen gas and salt, right? So we're going to predict that the products are hydrogen gas, and then we've got strontium and chloride. Well, chloride has what charge? -1. And strontium is going to become an ion. What charge does strontium ion have? 2+. I love it. I ask the question and the I's go to the periodic table. It's excellent. Because that's where the answer is. Strontium's in group 2, it forms a +2 ion. So then we look at the charges of these individual ions, and we see that we need 2 chlorides to balance the charge on one strontium ion. And so we have SrCl2 as our product. Then we need to balance. Is this equation balanced? No. The strontiums are okay. There's one here and one there. But over here we have 2 chlorides and 2 hydrogens. So we have to put a 2 over here and then we're done. These usually are fairly easy to balance. I did not, excuse me, I must have swallowed a frog. I did not include state symbols. What would the state symbol for this one be? Aqueous. How about strontium metal? Solid. Hydrogen? Gas. And this guy? Aqueous. Okay. How about the reaction of hydroiodic acid with barium oxide? Hydroiodic acid. HI. Very good. Any acid name that starts with hydro is just hydrogen and the ion. So iodic from iodine, we get HI. And barium oxide. Well, that's an ionic compound, right? Between barium and oxygen. Barium has what charge? 2 plus. And oxygen has 2 minus. So this is going to be BaO. Reaction of an acid with a metal oxide. What are the products? Water and salt. So acid with the metal, hydrogen gas and salt. Acid with a metal oxide, water and salt. So one of our products is water, and the other will be the salt that is formed between the barium ion and the iodide ion. So barium was 2 plus. We know from the periodic table that iodine is, or iodide is 1 minus. So that must be BaI2. How do we balance this?
Put a 2 in front of HI.
2 in front of the HI. There's 1 barium, 1 barium, 1 oxygen, 1 oxygen. Here there's 2 hydrogens and 2 iodides, and so we need a 2 over here. If you come to the point of balancing and you can't do it, check your formulas. If we overlooked, if we did this formula wrong and left the 2 off, would we be able to balance that? No, we couldn't. So that would be a problem. We'd say, hey, we can't balance this. It's impossible. Well, that's because we made a mistake. We fix the formula, and then we can balance it. Any questions? Base reactions, not as interesting. The most important one is the neutralization reaction. We've already covered that. The only other one we're going to talk about is the reaction of sodium hydroxide with aluminum and water. So this is a very specific equation reaction. We're just talking about this one particular of sodium hydroxide with aluminum. Aluminum is one of the very few metals that will dissolve in a base. Most acids will not dissolve in a base, but aluminum will. And so when aluminum dissolves in a base, you get this funky compound. And this is one of the compounds that we don't really talk about in Chem 20. This has 2 different cations, sodium ion and aluminum ion. And so, look, there it is. We're done talking about it.